Now, listen very carefully. So now, at point C, what is going to happen? Total internal reflection of spectrum is taking place. So from that point, it is traveling. The spectrum is traveling till point D. And this point D, what is happening? It is entering into the atmosphere or air. That is what we should call it as refraction is taking place. Because again, it is entering from one transparent medium to another transparent medium. Here air is there, and here water droplet, rain droplet. So it is entering from which medium to which medium? Denser to rarer. So it will bend away from the normal, and you can see the speed of light is increases, and whatever it is coming from this, from the point D, that is what we are seeing. Understand, Ra? That is what we are seeing. That is only we should call it as what? What is the name of that one? We used to call it as rainbow. What we should call? Rainbow. Now, in this rainbow, if you'll observe, totally how many refractions are taking place? 2 refractions. Understand? One total internal reflection. I will explain you now. Total internal reflection, and one more phenomenon is taking place. What is that? One dispersion. What is that? One dispersion. So this is all about. Understand, Ra? So formation of rainbow. This spectrum at the point D, whatever it is producing, the spectrum produced by the raindrop at this point, understand where it is coming outside, understand, atmosphere, it is only seen from the earth. That is what we are seeing from the earth. So you can observe here in this red, in this formation of rainbow, the red color of the spectrum always appears to be where? Always appears to be top. Where it is appears to be top. Who? Red color. Red color. You can see violet color appears to be where? Violet color appears to be bottom. Understand? Yeah. That is also important. Red color appears to be top. Violet color appears to be bottom. Do you understand, Ra? Understand? Yes, sir. You can see the formation of the 7-colored rainbow in the sky shows white light become into how many colors? White light become into how many colors? This is white light, and this becoming 7 colors. It consists of a mixture of 7-colored light. Understand? So we can see a rainbow on a sunny day if you look through a sperry of water from a fountain or any kind of waterfall with the sun behind us. So you can see not only the rain should fall, any kind of sunny day also, normal sunny day also. You can see from any kind of waterfall, through the waterfall or with the sun behind us. Whenever the sun is behind us, you can see from any kind of water fountain. Understanding water like from a fountain or something. Like a fountain means water is rising. Is it yes or no? Like this water is spilling up. Yes or no? Like these fountains also. Through these fountains, it will see when the sun is opposite to us, we can see the rainbow. What we can see? We can see the rainbow. So that is what you have to remember. Now, if you understand this, I have to say you one is that is what the total internal reflection. So I will explain you now what is reflection and what is total internal reflection. What is the main difference between them? I will explain. So also you can say. So they will ask you the one MCQ question. So we can see the rainbow also without rain also. How? We can see the sun when a spray of water from a fountain, or through a waterfall with the sun behind us. When? With the sun behind us. That is, you should note it down. Please write it. Then only I will explain that. Dina, are you there in meeting, Dina?
Yes, sir.
Yes, I will explain it now. Listen very carefully. Anybody having doubt, you can ask me. So now write it. Yeah.
So there will be lots of raindrops falling from during a rainfall, sir. In each of the raindrop, if the sunlight disperses, then there should be more groups of rainbow. So why can't it happen?
That is what I'm saying, Varshini. Have you noticed it? Suppose you can see the atmosphere is rain is falling from here to here. Suppose imagine this area to this area. Have you seen it? Suppose. Do you notice it? So you can able to see the rainbow thickness this much, not only here. Here it will form. Fully it will form. Do you understand?
Okay, sir.
I
Okay, sir.
understand, Varshini. It is forming fully. Wherever it is rain falling, rain will falls like this only. Is it yes or no? The band
Yes,
thickness
sir.
will be this much, but we are seeing from the only front surface. We cannot go like this and we cannot see current.
Yes,
You
sir.
understand? We are on the surface. Where we are on the surface of the earth. Only we can see front view. Understand?
Okay, sir.
Understand, Varshini?
Yes, sir.
Yeah, it is forming across the rain. Wherever it is rain is falling, across that it will form. But we can see it's like a line. Is it yes or no? That is what you are asking, correct?
Yes, sir.
Yeah, it is thickness, it is behind. We can able to see that. Understand? But normally we are on the surface of the earth. That is the reason. But if you are in a space, for example, you are in out of atmosphere, very close to the earth. By that time, you can able to see the 3D view. Suppose, see, I will keep you in front of you one. I will keep you one box. Which surface you can see? Only front surface. Is it yes or no?
Sir.
But you don't know the thickness of the box. You can able to see the thickness of the box. How much it is there? We cannot able to see, correct?
Yes, sir.
So rainbow is the same thing. We can able to see at this front surface, but backside it will be there. This is the thickness of the rain. Understand? But we are in front. We can able to see this one only. Understand?
Okay, sir. Yes, sir.
Now, please write it. We can also see a rainbow. We can also see a rainbow. We can also see a rainbow on a sunny day. Rainbow on a sunny day. On a sunny day, if we look through a spray of water from a fountain, water fountain, or through a waterfall, but sun must be water. Sun must be in front of us or behind us?
Behind us.
Behind us, with the sun behind us. Is it okay? So this is what about it. Now, total internal reflection of spectrum. Forget about the spectrum. What is total internal reflection? Reflection, I will say. Now, as we know that, first, at the reflection chapter, we have been studied the mirrors, plane mirrors and as well as spherical mirrors. Is it yes or no, guys? So,
Yes.
Plane mirrors or spherical mirrors, one surface is opaque surface, one surface is reflecting surface. Is it yes or no? Yes. Now, when any light will come and will hit this, again it will travel. After striking this reflecting surface, it will be retray itself in the same path. Or else, if it will come with any angle, it will go back into the same angle to the plane surface. That is called as reflection. What we should call, guys? Reflection. Understand? The reflection means after striking a opaque surface, the light will travel, bend into the same medium. Same medium. What we should call? Same medium is called as reflection. What we should call, guys? Reflection. Understand, Ra? Yes or no? Tell me,
Yes.
Yes, sir.
reflection. This is called as reflection. Understand? So the bending of light in the same media after striking into the any kind of opaque surface. Okay, like mirror, one side opaque, one side reflecting surface. Now, this reflection generally we have been studied in the first chapter itself, so we don't need to bother about that reflection. Now, what we mean by total internal reflection means total internal reflection will come into only in the case of two transparent mediums. When two transparent medium. Do you understand, Ra? Total internal reflection. Dina, total internal reflection, when it will comes means, observe very carefully. Now we are going to study. Internal reflection means, observe. So if you want to understand this total internal reflection, you have to know this concept first. That is what, let me take now. First one, all of you should say, from rarer to denser, light is entering, and from denser to rarer, light is entering. Or else, here let me take the denser. Here denser and here rarer. Now you tell me. So light, how it will be? What is the phenomena of light? Anybody? What is the phenomena of light? Now first let me take the rarer to denser. What will happen? Let me take, this is the angle of incident. Now refraction, how it will take place? Towards the normal or away from the normal?
Towards normal.
Towards the normal.
Towards to the
Is it
normal.
okay,
Towards
Dina?
to the normal.
Is it
Towards
okay,
the
Dina?
normal.
Tell me, Dina.
Sir.
Yes. Now, here angle of incident is, let me imagine, for example, 40 degrees. Now, angle of refraction will be less than 40 or greater than 40? Definitely,
Equal, sir.
it is
Equal
less
to
than 40. Ray Karthikeyan, less than 40 da. Because it will decrease as man, it will bend towards the normal man.
Okay, sir.
Always angle of incident is must be what? Greater than angle of refraction. This is what? When we have studied that, when the light is entering from which medium to which medium? From
Rarer medium to denser medium.
Anybody having any doubt in this?
No.
Now, observe very carefully. The same thing I am saying, the reverse one. Now, let me go for, in this case, now light is entering from denser to rarer. Let me speak. Everybody should speak. You have to tell me. Now, let me imagine. It is entering from denser to rarer. It is entering from where? Denser to rarer. This is what the actual path. Now, if the light is entering from denser to rarer, I have taught you from bending of light from the pencil.
Away from
Understand? It will move
Away
on.
from the normal.
Away from the normal. Is
Away
it
from the normal.
Dina, are you clear?
Sir.
This is the bending of light away from the normal. Clear? Any doubt? Anybody ask me?
No, sir.
No. Now in this case, this is called as angle of incident, and this is called as what? Angle of refraction. Is it clear?
Angle
Guys,
of refraction is greater than.
now speak all of you. If I will say now, observe very carefully. If I will speak now, angle of incident is less than angle of refraction or greater than angle of refraction? Less than angle of
Less
refraction.
than
Angle of refraction. Who is greater? Angle of refraction is only
angle of
greater.
refraction.
Is it okay, da? All of you? Yes or no? No.
Yes, sir.
For
Sir,
example,
denser to rarer, sir.
yeah. When it is entering from example, I am saying angle of incident is, let me imagine, equals to 40 degrees. Now, what about the angle of refraction? It is more than angle of 40 or less
More
than
than
angle?
40, sir.
More than-
More than, sir.
More than
More
40.
than 40 or less than 40? Confidently
More
say.
than
More
40.
than 40.
More than
More
40.
than
More than
More
40.
So can I take,
More than
let me
40.
take, for example, it is 50 degree. Is it okay, guys? Is it okay, guys?
Yes, sir.
Yes. Now, so first case. Now let me take again denser to rarer. Again the light is going. Now, then I inserted the incident ray with 50-degree angle. How much, Dena? 50-degree angle. So we know that this is denser medium, this is rarer medium. So now, incident angle itself become 50. Then what is the refracted angle? Arvind, Kevin? Refracted
Sir,
angle
greater
become
than 50,
definitely more than 50. So let me
More than
imagine.
50.
In this case,
More
it
than
will
50.
become. In this case, it will become 60 degrees. Is it okay, guys? Any doubt?
Yes, sir.
It is away from the normal, sir.
Away from the normal. So definitely it will be greater than 50. Is it yes or no?
Greater than 50. Yes, sir.
Yes or no? Now, let me go to the Nitinath. Nitinath will come and will check. Sir, I don't want 50. Now Nitinath and Nitish Kumar, they are doing. Sir, we don't want 50. We will go with the incident angle 60 degrees. What is that? 60 degrees. Now, Varshini, Bhumika, anybody can say Yalni. Definitely the angle of refraction is entering from denser to rarer. Now, angle of refraction is greater than 60 or less than 60? Definitely it is greater than 60 or less than 60, guys.
Greater than 60.
It will be greater than 60. Is it yes or no? Let me imagine.
Sure.
That angle is 70 degrees. Any
70
doubt?
degrees.
Anybody till here? Akshaya,
No,
very
sir.
good, Akshaya. Any doubt? So in this 60, 70. Now, let me comes to here. Yelamati and let me take some other Yalni. Let me take Yalni. Now, Yalni will come. Sir, I don't want incident angle of incident is 60. Let me take 70. How much I will take? Incident angle is how much now? 70 degrees. Do you understand, guys? 70 degrees. Now, what is the angle of refraction? Anybody? What is the angle of
More
refraction?
than 70, sir.
More than 70.
70. Is it yes or no? More than 70.
More than
So let me take.
More
Can I
than
take it
70.
is? Can I take it is 80 degrees?
Yes,
Is it
sir.
okay? Shalini, Dilip and Ray, Dilip and not at all responding. You come school, I will beat you, waste fellow. Why you are very silent nowadays? Starting you are very active. Now definitely it will become 80. Is it okay, guys?
Yes.
Yes or no? Now, let me go with another fellow. Let me take, this is Ashika. Ashika wants, or Prahasini, now, sorry. Now, Prahasini wants, sir, I want incident angle with 80 degrees. How much? 80 degrees. Incident angle become how much, Ra? How much? 80 degrees. Then, as we know that we have studied, just for example, like previous cases, what about the refracted angle? Anybody? Refracted
More
angle.
than 80.
More than 80.
So more than 80 means like every time we are increasing 10. So 80 means where it will goes? Definitely it will goes on the 90. Is it yes or no, guys? It is going on the exactly on the interface between the two mediums. Is it yes or no? Interface between the two mediums. Solra.
Sir.
Yes, Dina. Understand? It is exactly going at the interface. What we should call?
Sir, normal level, sir.
Normal
Normal
gone now. Normal gone. That is what interface. Understand?
Okay, sir.
This is only normal, Ra. This is only normal. This is only normal. Now it is going exactly at the interface. Where it is going? Kevin? Interface. So the refracted light ray is going interface. Where it is going? Interface. Now, just imagine. Now Arvind will come into the scene. When I increase the angle, just 80 become 81. 80 become how much, Ra? 81 degree. Then this must be also increases to 91. Is it yes or no, guys?
Yes, sir. Yes, sir.
Yes or no? Yes or no? Tell me, Ra.
Yes, sir.
Yes, sir. 91 degrees. So you can see 90 itself, it is caused interface. After, if you increase the 80 become 81, it is entering into the again same medium. Is it yes or no?
Yes, sir.
So if the light is entering into the same medium, what we should call this one called as? Reflection. What we should call? Reflection. But this reflection is taking place at between two transparent mediums. Is it yes or no? Two transparent mediums. Because of whom? Because of incident angle. Because of what? Incident angle. Now, till 80, we can call it as incident angle only. So once the angle reaches more than 80, example only I'm saying, more than 80, the light instead of reflection is taking place. So at that situation, whatever the angle is called as, that angle is called as critical angle. What we should call it, guys?
Critical angle.
Critical angle. Understand, Dina, now? Any doubt, Dina?
Yes, sir. Understood, sir.
Understand? So this is called as total internal reflection. What we should call it, guys? Total internal reflection. Any doubt anybody can ask me. So once the incident angle reaches to the critical angle where instead of reflection will take place, that angle is called as critical angle, and as well as that reflection is called as what we should call total internal reflection. Any doubt anybody? Honestly?
No, sir.
No, that is what. Very, very clear. Are you, Humaira? Are you clear, Humaira? Are you there in meeting? Humaira not there. Harini, understand Bhumiga? Arun Karthikeyan. So at a particular angle, where instead of reflection, total internal reflection is taking place, that is called as critical angle. And at critical angle, instead of refraction, the internal reflection will take place. That is called as total internal reflection. Understand? At critical angle, light will again reflecting into the same medium, that is called as total internal reflection. So this is what happening in the case of rainbow also. So you may understand it. At the angle B, the light is falling at which angle, Ra? It is falling at some certain angle where the dispersion of light is taking place. Is it yes or no, guys? Dispersion as well as refraction. Now, from B to C, whatever the angle of light, the spectrum is traveling, that angle, it is already which angle, Ra? That angle is called as what? Critical angle. It is happening naturally. We are not doing. It is happening naturally. So that is why here, instead of refraction, it should come like this only. Is it yes or no, Dina? Pranav, it should go like this. Yes or no? But if it will go like this, we will never see the rainbow. That is why nature itself, it is creating, it is making this dispersion of light fall at the another surface of the raindrop. This is the one surface, and this is the which surface? Second surface, another surface. So the dispersion light is falling on the second surface in such an angle. What is that angle called as? Critical angle. So that instead of refraction, total internal reflection is taking place. Then it is reaching to our eyes. Is it okay, guys?
Yes, sir.
This is what called as formation of rainbow. Now, if you go to the higher classes, +1, +2, or specialization in physics, we will study what is this critical angle also. Now itself, I am saying you that critical angle is between 50 degrees, 56 degrees to 59 degrees. Do you understand, guys? This is the critical angle of formation of rainbow. When the normal days, when the sunlight will fall, even though rain is coming, we will never see. Most of the time, even though rain is coming, the sunlight is there. We will never see rainbow. Have you seen, guys?
Yes, sir.
Yes or no?
Yes, sir.
But only particular situation we can see. At that situation, the raindrop, the light is falling on the raindrop between these angles. This angle is only, we should call it as what? Critical angle. But it is not there for you. Just for, I know I have an idea. Even I know how to calculate it and all. That is a very highly complicated process and all. We have to use an instrument. But it is not there for you. But that is why I am not saying you. But for your purpose, just for NTSC exams competition, you can remember. That is a critical angle between 56 to 59. And some textbook, they will give you 52 to 59 also. But exactly 56 to 59, you can remember that. That is called as critical angle. Critical angle of the dispersed spectrum, which is falling at the which surface? Second surface of raindrop. What surface? Second surface. If it is a raindrop, this is called as first surface, where the light is entering. At which point? B point. Understand? From B to C, wherever the light is falling, this is called as second surface. So second surface, the spectrum of light is falling with which angle? Critical angle. Critical angle. So that is what we should call as. That is why it is called as what? Not refraction. It is called as total internal reflection of. Reflection of what? Total internal reflection of spectrum. And at the point D, again another down surface, the refraction is taking place. That is what we people are seeing. We people are seeing at the down. This is called as rainbow. Understand? In rainbow, always red is in up, violet is in bottom. But whose bandwidth is more compared to the violet? Who is more visible? Blue color. Blue is more visible to us. That is why. Understand, Ra? Blue color is more visible because the availability of blue light in the white light is more compared to the violet light. But violet is at the least, but blue is more visible to us because it is amount available in the white light is more than blue light, violet light. That is why it is visible blue. Is it okay, guys?
Yes, sir. Okay, sir.
Sandra, any doubt? Anybody ask me? Nobody is responding. So now you can see in this also. You may listen very carefully here. Which is more thicker in color? Blue only we can able to see. Have you seen it? Blue, indigo, and violet. Because this bandwidth, the bandwidth of these two is lesser compared to the blue light. So blue light is the major portion and red light as well as. So that is why majorly we can see blue and red in the rainbow. And middle colors, the slightly we can see. Is it yes or no?
Yes, sir.
That is. So this is called as what is rainbow and the formation of rainbow. I hope you all are very clear with this. Any doubt you can ask me. If you'll understand this, then morning we will study the next important phenomena of nature called as atmospheric refraction. What is that? Atmospheric refraction. So with this, for today's class, if anybody want to ask me anything, you can ask me or else you can leave. Then are you clear with this? Total internal reflection?
Sir.
Reflection will take place at where? One surface must be reflecting surface, another must be what? Opaque surface. But total internal reflection will take place at where?
Two transparent surfaces.
Two transparent substances. If the angle, incident angle reaches to which angle? Incident angle reaches to
Critical angle.
critical angle.
Critical
That is
angle.
called as total internal reflection. So even which is not in there in our textbook, like a mirage, formation of mirage, that is also I will explain. Actually, it is not there in our textbook. You will study in class 8, but for you people for your better understanding, I will teach you that also in the tomorrow or day after tomorrow's class. But tomorrow we'll study atmospheric refraction, examples of atmospheric refraction. Mirage, that is a real example which you have to study. Formation of mirage is the most important atmospheric refraction. That is also I will explain you. Or else when you are traveling on the sunny road on the sunny day, you will feel that water is floating on the road. Have you seen it anytime? Anybody? When you are traveling on the road, sunny day, you will feel that near to you somewhere like a water body is floating on the road.
Yes, sir.
That is,
Yes, sir.
that is called as mirage. But exact mirage we can see in the deserts. That I will explain you clearly with the phenomena. So this I will stop the today's class. Thank you all of you. Bye.
Sir.
Thank you, sir.
Take rest and please again get back with your works. Yeah. Ask me, Karagan.
No, sir, I finished the chemistry video on